got a 54, 476 on my calculator Excel.
We have 15 years in ours. It's just ours is slightly different.
Oh, yeah, change the project life.
Okay, yeah.
Just change the project life, okay? Change the project life. Now, in this example here, I have my years going across the row. When you get my solution, the years will go across the columns. So what have I done? I've just flipped this array around. What was rows became columns, what was columns became rows. I realize it's more artistic than science. Which one is better? This one, or when you get the solution? Probably the solution is better, because you shouldn't put captions in columns. You should put captions in rows. That's just a rule of thumb. And years, time goes across columns. Okay? So when I did all the solutions, I wrote all the solutions for chapter 12, that's what I did. I flipped this around, yes.
And if you just want to see it another way, you just transpose it. You just copy it, right?
Yeah, just transpose it. Absolutely. Absolutely. Now, the other day we went over these columns. Any questions on these columns? Okay, now let's come down here and we'll look at the formulas. Payback. Before we can figure out the algebra to put in here, we have to think through what it is you'd actually do. And I think it was at that point that we stopped the other day. You can't write any formula, whether it was that cash budget one the other day. And the other day I said to you, take a piece of paper, go to the table, and think it through. And no two questions are the same. So I can't put up a model that would work all the time. You've got to do a number of examples. Ride the bike. Ride it over rough terrain, plain terrain. And then you learn how to do it. So we had one last week. We had a cash budget one with 3 formulas that were a little messy. We have something a little messy here. Now, don't look in the formula bar. Think through what it is you would do. And if you can think it through, then we can go write the formula. So if we're trying to determine the payback, which columns do we need to focus on? Well, we're dealing with payback, not present value payback. So if it's payback, then what we need to look at is the cash flow and the cumulative cash flow. Those are the 2 columns we should focus on. Now, if we're talking about payback, we need to look down this column and keep looking down here until you transfer from negative to positive. And once I know the number of rows that I'm going down, then I know when I'm transferring from not paid back enough to I've paid back too much. So if I look at the number of negatives, not in year 0, years 1, 2, 3, there are 3 negatives. So that gives me to the left of the decimal point. That gives me the 3. Now let's deal with to the right of the decimal point. So somewhere in year 4 is when I do achieve the payback. And it's assumed that the cash flow throughout the year, it's assumed, in all of this work, all of these textbooks, all firms, that the cash flow is linear. It's the same amount each month. And by making that assumption, we can take that 53 that we still haven't recaptured in the cash flow and divide it by that 71. So that 53 over that 71 will give me the 0.75. Now, careful. That 53, I think everybody's going to agree. Yes, I agree with you. That's the negative amount that I still have to recapture. That's the easy way. But careful. It's that 71, not that 71. And you say it doesn't matter. I agree in this case it doesn't matter. But why does it matter that I get that value right there? Because if it wasn't straight line, these wouldn't have been the same amount. So I've got to make sure that it is that value right there. So let's ignore that it's 71. It's the value right there. Okay, so now we can put the algebra together, the formula. So I'm going to look at that decimal point, and I'm going to first of all do the bit to the left of the decimal point, and then the bit to the right, and just put them together. So let's deal with the bit to the left. Count if. Count if. And thank goodness for highlighting. Count if. Count if I-14 to I-34. Because when this problem comes out to you, every student has a different number of years. And because you have a different number of years, I know that the project life, it will vary from 5 to 20 years. So depending on the student as to the number of years. Okay? So this formula will work no matter what is going on. So count it. It's less than 0. 1, 2, 3, 4. But you know that year 0 doesn't count. So what did I do? Count if minus 1. Minus 1. Okay? Count if minus 1 is going to give me what? 3. So I've got the bit, the digit to the left of the decimal point. Now, I could have written that a different way, couldn't I? I could have started it at 15, and thereby avoid the minus 1. I still get it right. So there is more than one way to do it. And both of those are fine. And you can see that it's been adjusted slightly. So I could start at 14 and have a minus 1, or start at 15. Any questions? Now let's deal with the bit that looks a little messy. The bit to the right of the decimal point. Okay? The bit to the right. Now first of all, it is preceded plus minus. So plus minus is going to give you what? A minus. That's going to give me a minus. But when we were just talking about this, when we were talking through what we want Excel to do, we knew we were going to add to the left and to the right. We were going to add them together. So if that's a minus, you can guarantee that this is going to send back, ignore that minus, just look at the formula part, it's going to send me back a minus. So the minus and the minus gives me a plus. Everyone okay on that? Well, let's have a look at it and prove it to you. Let's prove it. You know that when reading a piece of algebra, you must start at the innermost bracket. Okay, well, we could start, there's the divisor. So we could start with the numerator part or the denominator part. Let's start with the denominator part. And we know that we want that value that's sitting in year 4. Ignore the fact that it happens to be the same amount. We've already dealt with that issue. We want that value right there. So let's focus on the denominator. Here it is. Let's come into the innermost bracket. Count if I-14 to I-34. Okay? Count if less than 0. 1, 2, 3, 4. Plus 1 gives me 5. 1, 2, 3. Aha. That's getting me onto the correct row. Now the index. Index requires 3 parameters. Okay? So index requires 3 parameters. The array, the row, and the column. Well, count if gave me 5. That gave me 5. H14 to H34. H14. There it is. H14 to H34. That row, that array. H14 to H34. Go to the 5th row. And I gave it 0. It would have taken 1 also. And it also would have taken no parameter. It's optional. I passed at 0, yes.
Now, could you do the same thing for the denominator countif that we did for the first countif, in that start not on year 0?
Absolutely, absolutely, absolutely. But you can see that I was consistent, H14 all the way. So he raised a very good point. I went and changed my formula, right? So let's move it back, okay? So now it's showing I-14. When you do something, be consistent. So if I'm going to do I-14 to I-34 here, do I-14 to I-34. Okay? Don't mix. Don't mix. Why not mix? Because you'll confuse yourself. Yes, you'll confuse other people too, but you'll confuse yourself. Okay? Keep it simple. Try to keep it simple. You say, well, that's not simple. Folks, you've chosen a profession where a lot of what we do is very difficult. But try to keep what we're doing simple. Okay? Okay, so I found that 71, not that 71. So I've got the denominator. Now find the numerator. Now find the numerator. Well, look, I didn't do a +1. I did not do the +1. So that's going to give me that value right there. I, column I, it's going to give me a negative 53. So I have a negative 53, a positive 71, and another negative. So that gives me overall a positive. Overall a positive, and therefore I end up with 3.75. Questions? Okay. Now people are saying, well, I can just look down there and do that on a calculator. Of course you can. But that's not what you got to do when you leave here. You've got to do it in Excel. Okay? And these values change all the time. Now, let's do the book rate of return. book rate of return. First of all, the average income. Well, if it was not straight line, the average income would have been a different dollar amount. If it was not straight line. Because it's straight line, of course it's the same, 17,808. And then the book rate of return. This is an accrual accounting metric. All the others are what type of metrics? Cash flow. And some are discounting, some are not discounting. Firms use all of these metrics. They don't use them all at the same time, of course. And some firms prefer certain metrics, that one, versus net present value. The firms that prefer payback, probably those are the firms that don't have a balanced scorecard, and they focus on the short term or the long term. Focusing on the short term. Firms that use net present value are focusing on the long term, and they probably have a balanced scorecard also. Okay? Now, the net present value. Well, we have our cash flow, and we give it the formula net present value. But here's what you got to be careful of. The net present value, you'll notice that the formula, I have excluded the initial cash flow from the NPR formula. Why did I exclude the initial?
Because in Excel, the formula does it a little differently, and you have to add it back in at the end.
No, how about a better answer? Good effort.
Because it wasn't times zero, so you don't have a discount.
Yeah, the last part of your sentence was the right part. The last part, if you were to put the H14 inside there, it would assume it was year one and it would have discounted it. By bringing it out, it's not going to discount it. Okay? And it just coincidentally happens to be year zero, but it was the last part of your sentence when you said by leaving it out, it won't discount it. That's the reason we left it out, because we don't want to discount the 267. Everyone okay on that?
Yes.
Okay. Now, the net present value formula, it requires the cost of capital, two parameters, the cost of capital and the cash flow stream. Okay. And then the internal rate of return formula. That's from a previous semester. The internal rate of return formula. What do we give it? One parameter. We give it the entire sequence of cash flows. But if we go to help, you can give it a second parameter. I didn't. Okay, when I first brought it up, I did, and I took it out. Shouldn't have been there. You can give it a guess. Well, I did write up the discounting formula on the board the other day. I won't write it up again. But in algebra, what was that formula called? Can anyone give me that word?
Polynomial.
It's a polynomial. And there are how many roots to the polynomial? Well, because it was I to the power of t, there has to be t roots to that polynomial. And just to reassure you, I went back to high school algebra and I said 2x squared plus 3x plus 4, 2x squared How many roots would there be? 2. If you've got a formula from high school, 2x squared plus 3x plus 4, how many roots are there? Are you not familiar with that expression? Some people saying yes. The rest of them, I thought it was an accounting class. Why are we talking about algebra? Accounting is algebra. It's not a bookkeeping class. The computer does bookkeeping. Now, if you've got 2x squared plus 3x plus 4, how many roots are there? Well, because it's 2x squared, there has to be 2 roots. And are those roots, going to the next stage in algebra, are those roots real or imaginary? They're real. They're real, and every one of you knows how to solve 2x squared plus 3x plus 4. Every one of you knows how to do that. You had it in high school. Yes?
Isn't the root where it crosses the y-axis?
No.
Or the x-axis?
No. That's something else. That was y equals mx plus c. There's no regression. That was different. Now,
X equals to 0 at the root, so it crosses the y-axis there. That's
well, that was the difference. We dealt with that when we were doing cost estimation. Y equals mx.
But doesn't that still hold true to this polynomial? That root of polynomial is where it
No, because you got a constant term. 2x squared plus 4x plus 3. Plus 3. Okay? Now, there are polynomials that are very difficult. The discounting polynomial is unpleasant. And going to the next level in algebra, after you've realized the roots are real, there are roots that are imaginary values, meaning they can't be solved through normal algebra. That polynomial, discounting future cash flows, has only one real value. All the other values of I are imaginary. So when you put it into your TI calculator, as many students would do, when you put it in here, which is what I want you to do, my question the other day was, how does the TI, how does Excel find that one real root? How does it do it? Plug and chug, by trial and error. Goal seek, iteratively. That's how it does it. Well, if it's going to do it iteratively, Excel would like you and me to give them a hint where to start. Now, this is very much a carryover from 1990, when the computers were very slow. Because today, if you give it a hint and don't give it a hint, you won't notice any change in speed. They're so darn fast, the computers. So we omit it. We don't put a hint. We don't give it. Doesn't need it. Okay? So all we need to do here is just give it. All we need to do is just give it the cash flow stream as an array. Okay? And it will return the internal rate of return. And when I hit enter, that fast. Questions? Okay. Now the present value of the payback is just going to use two different columns. When we did the original present value, using those two columns, now we're using these two columns. Any questions? Okay. I modified this file last night and couldn't get to my website to upload it. Okay, because of the new security. Now, what did I do different to what you're getting? Well, I know what that final exam question is, so I was trying to give you a little bit of help. You ready? Here goes. what would that value have to be right there to have a net present value of, someone give me a number, make up a number.
10,000.
Okay, 10,000. Okay, we want that to be that, and what would that have to be? What would the savings have to be? How are we gonna do that?
Goal C.
Well done.
It's our goal.
So what I'm gonna have you do on your final exam is, for this problem, is not only do the capital expenditure, but a little twist on it, do goal seek as well. So let's do it. So how do we do it? Someone get me started. Where do I go? Data, what if analysis, goal seek. Now help me. Set cell, which cell? E30. To value 10,000 by changing done. Easy enough, wasn't it? But rather neat, isn't it? Rather neat. That if you and I are at Siemens and Siemens says, well, look, our stockholders want a certain return on investment, what do we have to get in terms of savings, in terms of cash flow? Goals. Now, couldn't we put together a data table where we looked at various amounts of net present values, and what would this have to be in here? So that's what I've done on the final exam. I have given you goal seek and data table again, but on capital expenditure. You with me, what I've done? Okay, let us now go to the next problem. Next one's a little messy. So what we did here is we got all the basics out of the way. What do I mean by basics? All of our metrics. Got all the metrics done. We got our basic calculations performed. Got our basic calculations performed. Here's the data. I only needed one additional calculation, but those who've already started working their multiple choice, you may need profit before tax, then do the tax calculation, profit after tax, and then add back the depreciation to profit after tax to get the cash flow. So this one was rather easy and straightforward. Okay? Now, let's come over here. A little bit more work involved here. You know that I'm not going to give you makers for your depreciation. I'm going to give you double declining balance. The reason I'm giving you double declining balance is because one of the functions on here is DDB. Okay? And there's a function on here, SLN, for straight line. But there's not a makers function on here. Why not? Because they don't have makers in New Zealand and England and Russia and Germany. That's unique to the United States, and Excel didn't put it out for just the US, it's worldwide. Okay? But there is double declining balance. So I've given you on the exam double declining balance. It actually makes this column easier. On the exam it's easier. Here it's messy. I'll show you. It's messy. Not nice. Okay? So, we're given sales. We're given expenses. Just those two lines. Sales and expenses. And you know up top here, it says expenses excluding depreciation. Okay? We're given sales, we're given expenses, no depreciation yet. Just those two lines, just focus on them. This is capital expenditure. What must we get to, cash or accrual? Cash, okay? So at the bottom, I've got to end up with cash, whatever it is I'm gonna do here in a moment. But I'm given sales and I've given expenses minus depreciation, classical presentation. So I've got sales, whatever it is, minus the expenses, but there's no depreciation. So I've got to go get something else. What do I have to get? I've got to go get the depreciation. And up here, it's makers, and you know on the exam, it's going to be double declining balance. So I've got to get those two, and then I get my profit before tax. And then I get my tax. And then I get the profit after tax. And you just told me what we want. Do we want accrual or cash flow? Cash flow. So the profit after tax, let's bring it back over here. There it is. There it is. What do I now have to do to it? Add, good. I've got to add back that depreciation. There it is. Add it back, and then I get to my cash flow. Got it. So I've got to put those calculations somewhere. Everyone with me on what I've got to do?
What's after depreciation? Can you just name those off?
Profit before tax, minus my tax, profit after tax. Ran out of space, brought it over here. Profit after tax, add back the depreciation, cash flow.